we want to talk a little bit about being lean in the model and die department and using a lean process. For a long time, dental laboratories have thought that more is better. And more is better isn't always the best thing for moving cases through the dental laboratory. What we'd like you to consider now is to think differently and a little bit outside the box that you've been normally used to thinking of. And think about products and materials that are going to help you do a better job in the dental laboratory. In the old days, we used to use simple products like these. Unfortunately, they didn't really address accurately what we needed to do. We've come a long way since then, and we're going to talk to you a little bit about some of the machinery and some of the materials that we're using now. The first thing that we'd like to talk to you about is a product called LeanRock. Now, LeanRock is a new product that's been developed by Whip-Mix to help address the fact that we need to move cases more quickly through the laboratory setting. I'd like to talk to you and show you just a little bit about how to manufacture in a lean method in the model and die department. We're going to first talk, if we can, about how we mix materials. We used to take these tools right here, regardless of the raw material that we were using. Sometimes we might have actually used a graduated cylinder to measure the liquid to put into the powder. Sometimes we tried to use a scoop to determine how much material we were to use. But the problem is that each of these powdered materials weigh different amounts, have different densities, and so 3 scoops of one is not equal to 3 scoops of another. Many times laboratories didn't use graduated cylinders to measure off their liquids. They simply took a bowl and kind of stuck it in the sink, mixed it up a bit to determine where they were, and away they went. That type of a method did not accurately reproduce the stone material each time. The water powder ratio is critical when we're working with these materials. When you don't critically look at the water powder ratio, you wind up with expansions that are different in each mix. Therefore each batch, therefore each case is a little bit different each time. With advances in technology, we've been able to improve the materials that we use and also the processing machinery that we use. So what I'd like to show you today is the combination of using LeanRock and using the Aquaspense SL and the VPM2. We used to do large batching. The technician in the lab would get in maybe 15, 20, 30 impressions, lay them all out on the counter, mix up a gigantic bowl full of material, and begin to pour their impressions. This was not the best way to do things, although it seemed like we were accomplishing a lot. It built in what we call in lean processing waste, and in this particular case, wasted time. We've got a lot of cases sitting and doing nothing while they're waiting for the stone materials to cure. If we work into smaller batches, we can start a group and move it through the model and die department and get it out to the waxers so that they can get going on it and push the case more quickly through the dental laboratory. The machinery that we're going to use this afternoon, we're going to start with the mixing equipment. Mixing has come a long way since the original Whip-Mix machines. We're now using digital technology, and we're using scales and weights so that we can accurately dispense liquids. We don't dispense powders here specifically so that you can use a multitude of powders and the same machinery without doing a lot of interchanging. This works by using the bowl that you're going to use. We place it on the scale of the Aquaspense. We push the tare button on the Aquaspense, which allows the machine to zero out the weight of the bowl. At that point in time, we don't need to measure the stone product that we're going to use. We simply need to pour it into the bowl. Now in this case, we're going to pour up 5 impressions. We need to pour in approximately 400 grams of material. So we simply can pour the material in, weigh it out. The Aquaspense will tell us what's inside of there. As soon as we have that material out, we have enough of the lean rock in the mixing bowl, we press start, and the Aquaspense will deliver the appropriate amount of water so that the ratio of 20 milliliters per 100 grams of material is achieved. When the correct amount of water is in, the Aquaspense will cheep at you and let you know that it's there. We simply pull that off. We do a little pre-stir that's easy to help us incorporate, and then we're going to use the VPM2. VPM2 is programmed already for the appropriate amount of mixing. In this case, we're going to pre-mix, and then we're going to mix solid for about 30 seconds. You're able to pre-program into the Aquaspense 15 separate programs and into the VPM230. This allows you to pre-program all of the different materials that you're going to use in your laboratory so that you simply need to push a button and they will consistently mix or dispense for you. Now, once this material has been completely mixed and the air evacuated out of that chamber, we're going to pull it out and we're going to go ahead and we're going to pour these impressions. One of the things that you do want to use is some type of a surfactant. In this case, we're going to use a product called Smooth-X. We simply spray a light mist on each of those impressions to help us move the material around. You do not want to spray heavily, and you do want to allow that material time to dry. When you're done and ready to go, the VPM2 is going to beep at you to let you know that your mix is complete. We're going to use the vibrator to help us remove the material off the paddle, which we'll place in the sink, and we'll begin the pouring process of these materials. Now, with lean stone, you have a shortened pouring time. You're going to have approximately 5 minutes to move this material from the time you begin mixing till the time your pouring is completed. So you want to first pour the tooth surfaces of each impression, and then we will come back and pour the bases. As you're pouring this material, you want to be sure not to over-vibrate. Over-vibration creates bubbles in your pour. To turn this vibrator up on high and hope that it drives all the air out actually produces the opposite effect, which is creating bubbles between the wall of the impression and the material you're pouring in. Now at this point, you can go back and create your bases simply by adding a larger amount of material. You don't want to overflow that material because it just wastes time and material when you go to grind off the excess to expose the palatal areas and the lingual surfaces. Now this lean rock is already beginning to set on us, which is why it's good to do this in stages like this. Okay. As we get to that point in time, we're going to get rid of the vibration that we're getting from our vibrator, and we're simply going to top off a little bit to make sure that we have enough for a base in each of these particular impressions. Now, in approximately 5 minutes from the time that we have mixed this material, the lean rock will begin to set, and we will be out of time for pushing the material around. So you want to make sure you're working quickly enough to have those models poured to the consistency that you want to. At this point, we're going to clean up a bit, and then we'll come back to the model grinding portion. Okay, now it's been about 15 minutes since we mixed that lean stone mix, or lean rock mix. Models are done, we pulled them from the impressions, and now it's time to grind on them. It's good to remember that before you grind on your materials, you just wet them down just a bit so that the material coming off the wheel doesn't stick in the inappropriate places and give you problems later. Also, it's good to remember always safety glasses. No matter if you've got a safety shield on your machine or not, this is the point in time where you need to have these on. All right, so we're going to turn this 12-inch model trimmer on now at this point. With this spray attachment, we're able to just simply wet down the model just a touch before we start. We have a base on here that allows us to do that, and then we're going to grind off all of the land areas and flatten out this thing. When you've completed the grinding on each of the models, it's a good thing to rinse them off just quickly, just to make sure you've got some of that slurry off of there. When you're done using the machine, it's a quick cleanup. It helps you keep your wheels from plugging up later and the machinery from clogging. And we move on to the next step. Okay, the models have all been trimmed now at this point, and we're about 20 minutes since we first mixed this lean rock material. Now it's time to remove the pallets and make sure that our border angles are good so that we can release these models from the base stone when we do that. This case we're just using an arbor band. You can use a router if you wish. You can use a model saw. Pull it out. We're just simply going to cut into here and remove that palatable area. Now you can see if we had overly poured the materials when we first poured these models, we'd be working a long time at this. This shouldn't take that long. Just a simple process. Make sure that we can easily cut the dies out in the near future. We're done. Right, the next step in the process is to drill the holes for the dowel pins in the bases. Now that we've removed the pallets from all the units, we're going to simply use a pinning machine. We've predetermined where those holes need to be drilled, and if we follow where the laser pointer tells us, we can simply drill the hole. We're going to need to put a hole for each of the sections that we need to remove. As you can see, we have those holes appropriately drilled. The next step in the process is to glue the dowel pins into place. We're just going to use a cyanoacrylate cement and our mainstay dowel pins. Dip the head of the cement in a little, or the head of the pin in a little bit of cement, and place that pin in the pre-drilled hole. It's good if you can set the pins off at about a 45-degree angle so that they'll only go in one way, and the individual die will only drop into the model one direction. This particular dowel pin is a single pin, but it has a very flat, wide surface on it that allows it to remain stable inside of its appropriate sleeve. Once the pins have been placed in each of the 5 models, we're going to use a little bit of accelerator to accelerate the set of the glue. With that accelerator on, we can then place each of the individual sleeves on each pin. And then attach the little booty to the top of each of the ends of the pins. These booties are going to help us later to uncover the bottom of the pin so that we don't have to drill around looking for it. With the pins all placed and ready to go, the next step is to use a separating medium, which will paint on to the surface at the base of our model. This is going to help us to separate from the next step, which is the flowstone base. Now, you might have noticed that I was scraping the bottom of the bowl at the end of pouring those models, and that's because we're trying to eliminate the waste that we have by mixing too much material and then just throwing it in the garbage can. It costs a lot of money over the years when we do that, and although Whip-Mix loves that, it's not really good for your dental laboratory. Now, we've pinned and based the models, or pinned the models, and it's time to base the models now. We're going to use a new product that's called Flowstone. Flowstone is going to help us to accurately and quickly put the bases on these models without going through the process of taking material, buttering in between, filling trays, and trying to mush that model down into those trays without trapping air. We're going to simply pour in there. So we're going to go ahead and we'll go through the same process again using the Aquaspense, only this time we've changed the program that we've pre-programmed to the Flowstone program, which is now going to run us 22 milliliters per 100 grams of material. Once again, we're going to place the bowl, we're going to push the tare button, the machine will zero out the bowl for us, and then we're going to add the appropriate amount of Flowstone. Now, it doesn't matter quite how messy we are at this point in time, because the machine is going to take care of that for us. We weigh the material out, push the start button. The machine will deliver the appropriate amount of water that we need, and we can clean up a bit of the mess we made. With that beep, we know that the program is completed, the appropriate amount of water is in the mix, and we're ready to go. Once again with VPM 2. These models have already had the pins placed, and they've been a die separating material has been placed on the base of the model so that we can separate the model itself from the base once the base hardens on us. Now, flowstone comes also in lean flowstone, which gives a little faster set than the regular flowstone does, so we can move these 5 models quickly along. In the amount of time that we were able to take 5 models and pour those and move them along, take 5 more and pour them and move them along, take 5 more and pour them and move them along, your original 15 to 20 models that you poured in a big batch hasn't yet hardened and been ready to come out of the impressions. With that beep, we know that the flowstone is ready. We're simply going to use the vibrator to help us to remove it a little bit from the mixer paddle, and then we simply pour the basing material into the molds. You pour it until it reaches up and touches the bottom of your model. You'll be able to see it wick up against the base, and that's when you'll know you're there. With that, your 5 bases are done. All right, now our models have now been pulled from the base formers, the ready formers that we used, and we have articulated this with a small plastic articulator. And now it's time to expose the pin bases. With the little booties in place, it's simply a question of picking them out, and that uncovers the end of your pin. Much easier than trying to drill around until you find it. We pick the individual booties out and we're ready to go. Now at this point we're going to cut out our main die, and so we simply pull the model work up. You can see that it exposes the bases. The dies can be cut apart with the pins exposed. You can see that they all come out very neatly and that your sleeves are retained in your model base. Now to help us cut this out without cutting into the base, we simply use a cotton roll. We can place that underneath our individual pinned areas, and then we simply cut out the die. Okay, now our individual die has been cut out, and now it's time to trim. We're going to do that with the aid of an electric handpiece, the appropriate shaped burr, and a little bit of suction. At this point, it's really helpful also to use some magnification. Whether you're doing this with loupes or with a microscope, your doctor is looking at this under magnification. You should be too. Now with the die trimmed, it's time to mark that margin. You want to mark that with a non-graphite pencil, so a regular pencil lead isn't going to do you any good here. In fact, it acts as an anti-flux when you're doing castings. So you want to make sure you're using something that's not made of graphite. Very quickly and neatly go around and mark your margin. At this point, you would block out any of the problems that you might see on your die. You might also take off any imperfections. And then it's time to place a little die hardener. In this case, we're using PDQ hardener. That hardener can be placed underneath the margin so that it can wick up into the marginal area. And it can also be placed on the die itself. However, you don't want to cover and coat the entire die. The reason for that is that the die spacer material will have a tendency to peel off if you do. Once you've got the die hardened, then you can put on your first coat of die spacer. With PDQ spacer, you can use gray, or you can use blue, or you can use a combination of both of them. Both are about 12 microns thick. So depending upon the wax that you're using and what you want to see as your background, choose the appropriate color. The die spacer should be painted on just short of the marginal area. And allowed to dry in between coats. The die spacer is there to allow for the film thickness of the cement that the doctor is going to use later. The second coat of spacer is applied, giving us about 24 microns of space. With the application of the second coat of die spacer, we're completed in the model and die department, and we're ready to go to the waxer. It's been just about an hour since we began this process, and we have 5 cases ready to move. In that hour's worth of time, had you poured 20 or 30 sets of models, you'd just about have 20 or 30 sets of models ready to pull out of their impressions. This way, your waxer isn't waiting. You're ready to go.